Hey guys, so welcome to this week's video of just all the questions you ran through last week. So we did, last week was a lot of trigonometry, and before we go into exam papers, I know I did it in the last video, but I think because trigonometry is all about the unit circle, I think I'll just kind of do a little refresher on the unit circle and its applications and how it's related to trigonometry and triangles and stuff. And then we can see how I'll go over the kind of tools we can use in trigonometry, and then we can see how they're applied in exam questions. So the unit circle. The unit circle is a circle of radius 1 centered at the origin. And so because this is 1, that means this point is 1, 0. This point is 0, 1. Sorry. This point is minus 1, 0, and this point is 0, minus 1. And so why is this useful? Well, if we want to pick out certain points on the circle, there's two things that can describe it. How far we go out and how far we go up. And how far we go out is going to be obviously the radius of the circle, which this point is 1. And how far we go up is going to be the angle that we go up at. So this, and that'll be the angle we go up at. And so why that's useful is because mathematicians have basically decided to relate the x-coordinates and y-coordinates at this point to the angle that we need to go up at. So they said the x-coordinate at this point is going to be cos theta, and the y-coordinate is going to be sine theta. So if we imagine dropping a kind of line down like that, our x-coordinate, so how far out we have to go, is going to be cos of our angle, and our y-coordinate is going to be our sine of our angle. And so why that's useful is because if we forget about the unit circle for a minute, if we think about just a right angled triangle like this, and we know its hypotenuse is 1 and its angle is 30 degrees, how are we going to find the length of this side? Well, if we relate this back to our unit circle, this kind of looks exactly like the triangle we have here. It's a right angled triangle. We have a hypotenuse of 1. Our angle was 30 degrees in our other triangle over here. So let's sub in 30 there. And this bottom side is what we're trying to find. So let's say that's x. And so x is this bottom side, but this bottom side is also the cos of the angle. So we can say that x is equal to the cos of the angle, in this case is 30 degrees. And that'll give us, if we put that in our calculator, root 3 over 2. So that means how far we have to go out here is root 3 over 2. And if we keep going with our question, so if we want to find out how high we have to go, well, how high we have to go is y, but how high we have to go is the y-coordinate is sine. So that means y is equal to sine 30 degrees. And if we put that in our calculator, that'll give us 1/2. So now we see that, we see that we have to go out root 3 over 2 and up 1/2 to get to this point. And so that's the exact same thing. We have to go out root 3 over 2 and up to get to this point. And so we've successfully found a way to find x and find y. Okay, so this was great, but we just said that this triangle was exactly like this triangle here. But what if this triangle over here was our hypotenuse of 3? What would we do then? Well, if we go back to here and we think about, I'll just do this for a second, and we think about stretching our hypotenuse up like this so that it goes 3 wide. So imagine stretching is 3 times as high, so 1, 2, 3. Then our circle is going to get just as big. So let's see, a little bit bigger. And center that back. So our circle is going to get that big, and that also means our heights and our widths are going to get that big. So that means our hypotenuse is multiplied by 3. That means our width is our x coordinates multiplied by 3, and our height coordinates multiplied by 3. And you can see that from the coordinates of the endpoints. Before, our endpoint was 0, minus 1, but now because it's radius 3, this is going to be 0, minus 3, and this is going to be 3, 0, and this up here is going to be 0, 3, and minus 3, 0, because our radius, how far we have to go up, is 3. Okay, so that means all our heights and widths are multiplied by 3, and so all we have to do over here is multiply our heights and our widths by 3. And so that means x is 3 cos 30 and y is sine cos 30. And if we put, that means, we can just multiply these by 3 as well. And if it was 7, you could imagine stretching this hypotenuse out 7 units and then making the circle bigger, and all your widths would go by 7, but we won't do that. We just have to multiply everything by 7. 7, 7, 7, 7. And so if we kind of forget about what we had down for a minute, if we have a right angle triangle with angle 30 degrees and hypotenuse 7, and we want to find the x, well, we know that our x coordinate is our cos, like our unit circle tells us, cos 30, and we have to multiply everything by 7. Great. And the same thing for our sine. So think about stretching it out and stretching it out. And this should kind of make sense with what you've learned before, because in third year you did sa, ka, toa, which is sine, cos, and tan, and opposite hypotenuse, adjacent hypotenuse, and opposite adjacent. And so what this means is, if I kind of get these out of the way for a second, just put them down here for later use. We know our angle is here, so our opposite's going to be opposite, our adjacent's going to be there, and our hypotenuse is going to be there. And we knew that if we're doing the sine of our angle, it's 30 degrees, we know that that's going to be equal to opposite over hypotenuse. So opposite over hypotenuse. And we said that was y. And if we want to find y, our opposite's going to be y, and our hypotenuse is going to be 7. And if we want to find y, we just have to multiply across by the hypotenuse, or 7, equals y. And that's exactly what we have down here. Y is equal to 7 sine 30 degrees. And same thing, if we wanted to find a, we know a over in our hypotenuse, we use cos 30 degrees is equal to a, which let's call it x for a second, x over the hypotenuse is 7. We multiply across by the 7, and that'll give us 7 cos 30 degrees is equal to x, which is exactly what I had before. So this should all kind of make sense with what we learned before, but in third year they just don't tell you where it comes from, and where it comes from is the unit circle. And so, well, what if we wanted to reverse this question? What if we wanted to say, I'll just kind of tidy up my unit circle for a second, and we'll draw a new one. Okay, so we'll go back to radius 1, 0, 1, minus 1, 0, 0, minus 1. And what if we did the same thing? We had a point, we go out, we go up to our point, this is our angle, and we want to, we drop our line down, so we have our cos theta is our x, and sine theta is our y. Say we knew this was root 3 over 2, and we wanted to find out what angle that means. So if we knew that this x here was root 3 over 2, what does that mean for this angle? And we knew our hypotenuse is 1 because it's radius 1. Well, if we think about it, we know our x coordinate is root 3 over 2, but we know that's equal to cos theta. So we can write that. Cos theta is equal to root 3 over 2. And I think of theta as like a function. So we're putting our input as theta, and we're getting some kind of an output. And so if we think back to our previous questions that we did, remember the phone sales and the months. If we have a function, say that was 13 over 5 minus x, if this was the months and this was the number of sales, we were inputting a certain number of sales, and it was telling us how many, or a certain number of months, and it was telling us how many sales we would get. So we would put in 3 months, say, and it would give us 13 over 2 would be our sales. But then in the next question, we found out, what if we had a certain amount of sales, 30,000 or whatever, and we wanted to find out how many months that took? So x here. Well, what we found out is that we have to work backwards. So if we want the output instead of the input, we can just multiply across by our denominator, and then divide by our output, and then get x on its own, so bring it over here, and bring all this and bring it over here, so kind of swap those. So 5 minus 13 over f of x is equal to x. And so now, instead of inputting months and getting sales, now we're inputting sales and getting months. So this here is our input. And remember, inputs, like the function we had, let me scroll. The function we had up here, our input was just called x. So let's just call this x. And our output was called f of x. So let's call this f of x. But to kind of make it different from the function we had before, so not to get confused, we're going to say this is minus 1. So it's the opposite of f. It's the inverse function of f. So we're doing the opposite thing. Instead of inputting months and getting sales, we're inputting sales and getting months. And so what mathematicians have done, and it took a bit of work, so that means we don't have to, it's not on the syllabus, we don't have to find it, but what they found out was they also got an inverse for cos. Instead of inputting the angle and getting some kind of number, we're going to input some kind of number and get an angle. And what number are we going to input? We're going to input root 3 over 2. And that's going to give us our angle. Another way to think about it would be, think of cos inverse as the opposite of cos. So if we think about it like our logs and our bases, if we take the cos inverse of both sides, like we took the log of both sides to get rid of the e, the cos inverse is going to be the opposite with the cos, so it's going to cancel and leave us just with theta. And then this here is just a number we can put in our calculator, cos inverse root 3 over 2. And what that'll give us is cos inverse root 3 over 2, and that'll give us 30 degrees, just like we were expecting. So because, remember, if we go over here, I think I rubbed it out, maybe. Yeah, but when we had the hypotenuse of 1 and we had cos 30 degrees, that would give us root 3 over 2. So now we've just done the opposite. We knew it was root 3 over 2, and we worked backwards to get the angle. We knew it was 3 over 2, work backwards, get the angle, 30 degrees. Perfect. Okay, but the problem is that this here is a width of root 3 over 2 we saw, but there's 2 points on this circle that have a width of root 3 over 2. If we kind of drop this line down like this, and we go to here, this point here, I'll do it in red, also has a width of root 3 over 2. So it also shares the same x-coordinate as this point up here because it's directly underneath it. But the problem is that this angle is different because we always take the angle going like this. So this one stops here, but this stops here, say. But this one doesn't stop until it gets around to here. So how are we going to find this angle, this big one? Let's call it alpha. Well, how are we going to find alpha? Well, we just got to count them up. So we know this one is 90, this one is 90, so that's 180, this one's 90 again, so that's 270. And now we just need to add on this little extra bit. But we don't know that bit. So one thing we could do is we know a full circle is 360. We know this angle in here is the exact same because it's symmetric. So this one is the same as this one. So what we can do is do 360 minus whatever our angle was. 360 minus, and we found out our angle was 30. And so that means 330. So that means we did the inverse of root 3 over 2, and we got the inverse on your calculator will always give you this one here, the very first one in the first quadrant, but we know there's also another one that'll give us the same answer, and so we need to include that. 330 will also give us the same answer, and you can check that because if you do cos 330 in your calculator, that's going to give us root 3 over 2. And the same thing for sine. If we wanted to find out how tall this was, or if we knew this was a half, and we wanted to find what angle that happens at, so we knew sine theta is a half. We need to find the angle, so let's take the sine inverse of both sides. And we know this will cancel with this, and we're left with theta equals sine inverse a half. If I put that in my calculator, we're going to get 30 degrees again. And because I just picked it because I knew it would be 30 degrees. But yeah, it's going to give us 30 degrees. But the problem is this height of a half, let me do it in green maybe, is also shared by this point. This point directly opposite will also be a half. And so then if we draw this, if I get rid of some of these, if we draw this line back to the origin, that means this angle gives me a half because it goes up to here, but this angle here also gives me a half. And so what is that? Well, let's count up 90, or we know this whole line is 180, and we can do 180 minus our angle. So this whole line is 180. We know we want this one. We know this is the same, so we can minus half. So 180 minus 30 is going to give us 150. And if we check that, if we do sine 150, that'll give us a half. So there's always two angles that can give us the same thing. So your calculator will always give you this very first one, but we need to make sure we don't forget about the second one that it can give us, because we need to remember that the circle is symmetric. Okay, great. So those are the kind of two tools that we can use for angles, right angle triangles. So if we have a right angle triangle and we have, say, hypotenuse 7, if we know this side, let's say it's 6, and we want to find, let's not do the angle first, let's do the side first. So if we know this angle is 30 degrees and we want to find the side, well, we know the x-coordinate is cos, and we know instead of theta, we can just put in 30 degrees, and that'll give us root 3 over 2. And same for y, we could say sine 30 degrees is a half. Okay, great. And now if we wanted to work backwards, we know this height is a half. Oh no, sorry, this is why I put the 7 in, so we need to multiply everything by 7. Don't forget that. I almost did. Whatever, yeah. Multiply everything by 7 down here. Okay, great. And if we have, this is a half, let's say that the sine of the theta is going to be a half. And then if we do the inverse, so sine inverse a half will give us theta, and that'll give us 30 degrees. And then we need to understand that there is another angle, but for this triangle, there's only one angle that we can use. But technically, there is always a second angle we can use, and we're going to see that now in this question. So those are the kind of two tools we can use. You can still use it in the SOHCAHTOA way if you want, if you prefer that way from what we learned before. So if we knew that this was 30 and that was 7, and we wanted to find x, we could say cos of 30 is equal to a over h. A is x in this case, so that's x over 7. Multiply cross by the 7, cos 30 degrees is equal to x. And that'll give us exactly that. So you can still do it the SOHCAHTOA way if you want, or you can do it the unit circle way. Okay, so with all that in mind, let's move on to our very first exam question, and let's answer this. So it says, if sine 3a is equal to minus root 3 over 2, find the values of a. Okay, and so a here is our angle. Remember, think of this like the theta. And we might even rename it theta, and then kind of change it back to 3a at the end. So let's say sine of theta is minus root 3 over 2. So what does that mean for our unit circle? Let me just clear some of this up if I can. There we go. Okay. Well, let's think about what sine is. Sine is our y coordinate, cos theta, sine theta. So that means it's a height along here somewhere. And so this height is negative, and so it's below the x-axis. Because if it's negative, then we're down here. This is a negative height. And so that means we're going to have some kind of a height here and here of minus root 3 over 2. Because remember, these points share the same height. So we do minus root 3 over 2 is this height here. Okay, and so what angles will those make? if we draw the lines connecting back to them, well, this one makes an angle of this, and this one makes an angle of this. So we need to find those. And a way to do that is, we know that, our theta is stuck in our sine, so we're going to do the sine inverse. So sine inverse root 3 over 2 is equal to, and we'll leave out the positive sign for a minute. So let's do sine inverse root 3 over 2. That's 60 degrees. So that means, remember we left out the positive sign, or we left out the negative sign, so it was a positive sign. So this is positive root 3 over 2, and that means that this angle here is 60 degrees. And so now we need to find out how this relates to these angles. Well, if we think about it, this one is on a straight line from it, so we just need to add 180 degrees to it. So let's do that. 180 plus 60 degrees is going to be 240. And, if we think about this big angle here, remember what we did the last time? We knew a full circle was 360. We knew this angle in here is also 60 because it's symmetric. So we can do 360 minus 60. And that'll give us 300. And so that means if we do, let's always check your answers. If we do sine 240, that'll give us minus root 3 over 2. Perfect. And if we do sine 300, that will hopefully give us minus root 3 over 2 as well. But we're not finished. So we know theta could be 240 or 300. But at the very start, we changed it from 3a, and we're trying to find a. So this is 3a is equal to 240, or 3a is equal to 300. So a is equal to 240 divided by 3, 80, and a is equal to 100 degrees. Great, so that's that whole question done. And you see now why we need to understand that there's multiple angles with the same height. And because our calculator will only give us this in the first quadrant, we need to forget about this minus sign for a second, get this angle, and then use it to work out the other angles. But great. Okay, yeah, those are those takeaways from that question. Finding this angle in our first quadrant, using it to find the other angles, and then understanding that there's 2 for each point. Great. Okay, so that's that question done, and on to the next question. Okay, so we've learned what we can do with right angle triangles, but what about what we can do with non-right angle triangles? So say a triangle was just looking like this with no particular right angle, and say so none of them are right angles, let's just call them A, B, and C, and let's call the opposite side with just the same name but a lowercase. So A, B, C, so opposite to A. Okay, so what are the kind of tools we can use to figure out things about non-right angle triangles? Because obviously, when we're thinking about the unit circle, once we get a point and we drop down this, it's always going to be right angle to the x-axis. So how are we going to find out things about non-right angle triangles? Well, if we think about, I should have drawn it in 3, but okay. If we just think about C and C for a second, maybe I can rotate them. Oh yeah, perfect. If we increase the angle of C to make it slightly bigger, and we add on a little bit here, that'll make the length of C slightly longer. So if we went back to what we had before, something like that, this was our C, and then we rotate it out. Now have to add a little bit extra to make up that extra space. And same thing if we, I'll just draw it this time, if we decrease the angle of C, that means C gets shorter. And so if we think about then the other angle we had, so like A, let me draw it in 2. If we think about A, and this was our side A, if we increase, let me not, a little bit too far, if we increase A, that means A is going to get longer. And if we decrease A is going to get shorter. And so what they figured out was that there's a relationship between the angle in between the lines and the length of the side opposite the lines. And we don't need to figure out what that relationship is. We just need to know that it's the ratio between the side and the angle. So the ratio just means dividing, so the rate of change. And so the rate that the side gets longer is pretty much directly proportional to the rate the angle increases. And why I was talking about A as well is because they figured out that this is the same for all sides of the triangle. So the rate that A changes with respect to A is the same as the rate that C changes with respect to C, and the same way the rate B changes with respect to, that should be a capital B. So, and it kind of makes sense. It's kind of intuitive, it seems like we shouldn't need a rule for it, but it's kind of useful because if we have this triangle like we had before, A, B, C, now we have it all in one triangle. So if we think about how C gets bigger, C should be over here. C gets bigger, neither two change, and C gets bigger. That means A also gets bigger. You know what I mean? Like they're all related. So the rate of change from C to the rate of change of the angle is the same as how much A changes when A changes, and how much B changes when capital B changes. And so they're all the same. And why that's useful is because, let's pretend we have this full triangle. If we knew that, or say we wanted to find this side A, and we knew that this angle opposite was 30 degrees, and we knew two opposite angles. So we knew this was 7 and this was 60 degrees. 60 degrees, say. Well, that means we know these two are related, and it's related in the same amount that these two are related. So, and that's expressed over here. So C and C are related in the same way that A and A are related. And why that's useful is we want to find A. So let's plug in everything we know. We know small c was 7 over here. Big C was the angle, so it was 60. Big A was the angle, so it's 30. And small a is what we want to find. So now all we have to do is multiply cross by sine 30 degrees. So if we cross multiply by sine 30 degrees over sine 60 degrees, that'll give us A. And whatever that happens to be, we can just put it in our calculator, sine 30 over sine 60. And that'll give us 7 root 3 over 3. And so that means this is the length of A, 7 root 3 over 3. And we can go like that no matter what side we're trying to find, as long as we know two things opposite each other, so how they relate to each other. So 7 and 60 are related. We now know that 30 and 7 root 3 are related. And so if we knew this was 90, so this is, I accidentally chose a 90 degree angle, but whatever, let's just pretend this is 30 again. So now I have two things related in either one of these, this one or this one, and I have one thing of this, and I can use it to find this one because they're related. And so that's basically the sine rule, using opposite relations. But what if we don't know opposite relations? What if we know, what if we're trying to find A like before? We know that's 30, we know that's 7, say, and we know that's 3, and we don't know anything else about the triangle. Now we don't know anything opposite. We don't know this one is related to that one, and we don't know that one's related to that one. And so how are we going to find A? We can't use the sine rule because we need two opposite things. So another rule we can use is something called the cosine rule. And it's kind of useful to think about because if we can't use the sine rule, sine is kind of like the opposite of cos. And so if we can't use the sine rule, we can use the cos rule. And so another way to kind of think about it is if we have two sides running into the same angle, so this side runs into the angle and this side runs into the angle, and the angle's opposite the side, then we can use the cos rule. And what the cos rule says is it's kind of big and long, but basically says if we want to find this side, we have to square it. So this side is equal to the two sides running into them squared and added. So 7 squared plus 3 squared. So 7 squared plus 3 squared. And then minus 2 times the angles or the sides multiplied together, 7 times 3, and then the cos of the 30 degrees, hence the cos rule. And so this is just some kind of a number. Let's pretend it's 49 for a second. and that means a is equal to 7 because we just square root 49. Okay, so those are two kind of rules for non-right angle triangles, sine rule and cosine rule. And these are both found in your log tables, so you don't need to remember them. But once you kind of understand what they're doing, you kind of remember them anyway, because the sine rule is just the relationship of the opposite sides, so you put them over each other. And the cosine rule is a little bit more difficult to remember, but just think of two sides running into the same angle, and so then you use just those sides of the angle. So you square them, multiply them, and then you get the cos of the angle. And the more you use them, the more you'll remember them anyway, so I wouldn't be too worried. Okay, so this is our toolbox for non-right angle triangles, whereas our toolbox for right angle triangles was just cos theta and sine theta, and maybe tan theta if we're thinking outside the box. But okay, so on to how they would ask this in an exam question. So it says the triangle ABC is shown in the diagram below. AC, so this line here, is equal to BC, this line here. Okay, straight away that means this is an isosceles triangle. ACB is equal to 45 degrees, and AB is equal to 10 root 2 root 2 minus root 2. So there is actually two ways we can do this. We know this is an isosceles triangle, so that means this side is the same length as this side, so this means this is 10 root 2 minus 2 root 2. And so what does this look like? Well, this looks like what we had before. We had two sides running into the same angle. Oh, no, wait. Sorry. I've gotten that wrong. AC is equal to BC. We're trying to find AC. Sorry. But we know that it's an isosceles triangle. So we know that these angles are going to be the same. So that means 180 minus 45 degrees is equal to 135. Let me just check. Yep, 135. And then so these angles are 135 divided by 2 each, which is 67.5. Yeah, because AB is down here. Sorry, they already wrote it into the question. I got it wrong. So isosceles triangle, these angles are the same, 67.5. And so now if we think about what this means for what we were doing before, I'll draw a nicer triangle maybe. We know an angle, so we know this angle. We know this side, 2 minus root 2. And so straight away we can think that we know two sides opposite each other, so we know how they change in relation to each other. So that means we're going to use the sine rule. And we know this angle is 67.5 and this angle is 67.5. So that means we know how these relate to each other, and so that means we know how these relate to each other. So we can use the sine rule while trying to find AC. And so let's call this AC. So that means the way these relate to each other, AC over sine 67.5 is going to behave in the exact same way as how 45, as the way this side, 10 root 2 minus root 2, all over sine 45. Just a small thing as well, keep the signs either above the line or below the line. We could flip both of them and it would still make sense, so we could write the sine on the top and the AC on the bottom, but then we need to make sure the sine 45 is above the 10 root 2 minus root 2. Okay, so now how are we going to find AC? Well, all we have to do is multiply across by sine 67.5. So 10 root 2 minus root 2 times sine 67.5 all over sine 45. And this is some kind of a number that we just put into our calculator. Go on, let me do it. Why not? So 10 root 2 minus root 2. Make sure that second root 2 is below the first root. Sine 67.5 over sine 45. And let me put brackets around everything. Oh yeah, so there's a second bracket. Sorry, now. There we go. So this is equal to 10 units. So this here is 10. And that's the whole question done. Great. So takeaways from this question, two tools that we can use for non-right angle triangles, sine and cosine rule, and two things, well, maybe three things we can use for right angle triangles, cos, sine, and tan. Okay, great. So on to the next question. Okay, so next question, we kind of looked at how we might use trigonometry in the real life. So it says, AB is a vertical tree standing on horizontal ground. In order to estimate the height of the tree, so this is AB, this is our height of the tree, which I think is already marked H. In order to estimate the height of the tree, Keen stands at point C and measures the height of the tree, and then he measures the height, he measures the angle of elevation, so he measures 32 degrees, and then he stands at point D, which is 12 meters in, and measures 58 degrees. And we have to use that to calculate AB. So this is something you could do in real life, and that's what people do as well. Surveyors and that kind of thing. If they want to see how tall a mountain is, how tall a building is, that kind of thing, they'll just point some kind of a telescope or binoculars up to the top of it, measure the angle, then move closer, look to the top of it, and because of this change in angle, they can figure out how it's going to change in height. So let's do that. Okay, so we're trying to find h, the height, so let's work backwards and see what we need to find that. Well, we know h, the height, is in two triangles. It's in either this big triangle ABC, or it's in this smaller triangle ABD. And so what would be easier to use h in? Well, let's think about it. Here in this big triangle, we know the angle is 32 here, and we know a little bit of it here is 12. In this triangle here, we know the angle is 58, and it's a right angle triangle. Okay, so that might help us. So, basically, if we find out something about this triangle, we can use it to find out about h. And how are we going to find out something about this triangle? Well, we can use, we know this angle, and this is the opposite side. So that's leading me to the sine rule. Let's see if we have another side. Let's see if we can get this opposite angle. Okay, so how are we going to find this opposite angle? Because then we can use this opposite angle to use the sine rule to get this side, and then we can use sine, cos, and tan to get h. Okay, great. So how are we going to find this angle? Well, we know angles in triangles add up to 180. We know this is 58, this is 90, and so this must be 180 minus 58 plus 90. I'll put that in our calculators. 180 minus 58 plus 90 is going to be 32. So this angle here is 32. Oh, and actually that doesn't help us get any closer to this angle. So we've gone a little bit of a goose chase there, but that's okay. So what would help us get this angle? Well, we know this triangle here, the angles will also add up to 180 degrees. So if we find this angle, we can use it to find this angle. How are we going to find this angle? Well, this angle is just, it's on a straight line with this angle 58, so it's 180 degrees minus 58. And 180 degrees minus 58 is going to be 122. So this here is 122, and then we can do 180 minus 122 plus 32, and that's going to be 122 plus 32, 26. 26. So this angle here is 26. Okay, so we have this angle, and what were we going to do with that? Let's think about what we were doing. We're going to use this because it's opposite this, and we're trying to find this. We can use, because it's opposite, we know we can use the sine rule. Okay, so let's label this side x, say, and let's try find that. So we know that the rate of change of x to this angle 32 is going to be the same as the rate of change of this side here, 12, to this angle here, 26. So then if we want to find x, we just have to multiply up by sine 32. So x is going to be 12 sine 32 all over sine 26. We put that in our calculator. 12 sine 32 all over sine 26. That will give us 14.5. So we know x here is 14.5, and now we can find h, because we know something about these angles. It's a right angle triangle. We know the hypotenuse. We can use it to find h using our SOHCAHTOA. Okay, so what do we know? We know if we use this angle 58, we know opposite and hypotenuse. So we know that's SOH, opposite hypotenuse, so we can use that. So sine of 58 is going to be, in this case it's h. It's confusing because we have two h's, but why don't we rename this y? Because then we can say sine 58 is y over hypotenuse, which in this case is 14.5. Then we can multiply across by 14.5. Sine 58 is equal to y. We put this in our calculator and we get 14.5 sine 58. We get 12.29669, which is going to be 12.3 if we round up. Okay. Another way we could have done this instead of doing SOHCAHTOA is if we think about what our triangle was. We had this y, we had 14.5, and we had 58 degrees. So if we think of our unit circle, but now instead of radius 1, we're going to do radius 14.5, and we're trying to find y, and we know this is 58. Well, we know y is the sine of our angle, so sine 58, and we know since our radius grew from, usually we think about 1, a unit circle is 1, but we stretched it out by 14.5 units, so now we have to multiply it by 14.5 units, and that will give us the exact same thing. Okay, great, so that's the whole question done. We found the height of the tree. It was, I think, 12.3. Oh, corrected 2 decimal places, so let's say, yeah, it would be 12.30. 0. Okay, and that is the question done. So that is how you would use trigonometry in the real world. And we'll move on to, so actually, before we move on, takeaways from this question is working backwards from what we're trying to find. So in this question, we were trying to find h, so we needed to work backwards to find out what we needed to find h. We figured out that if we find this side of the triangle, we can find h. And then we said, how do we find that side of the triangle? Well, we can find that side of the triangle if we use the sine rule with this side and this angle up here, but we didn't know this angle, so we need to find this angle. How do we find that angle? Well, we can do the angles in the triangle add up to 180. And finally, we have enough information to get this angle, then that gives us the side, and then that gives us the final answer. So it's about working backwards. Okay, but on to the next question. Okay, so next question was kind of similar in that we're using trigonometry in the real world to find something out about that. So this one says, Olga wants to measure the vertical height of a hill. The point H is at the top of the hill, and points O and Q are 20 meters apart on the horizontal ground at the bottom of the hill. Okay, so we know these are kind of flat to each other on the same ground. That's what on the horizontal ground means. Olga measures the angle of elevation from O to H. So O to H here is 17 degrees. And then O to H, taking O to be the point directly below H, this one here, that is horizontal, so all of this triangle is flat on the ground, basically is what that's saying. Olga also measures the angles OPR, OPR, so that's 87, and ORP, so ORP, 88. Okay. All of these are shown on the diagram below, not to scale. Work out the distance OH, so we're trying to figure out this distance here. Okay, let's call this X, why not? Let's call it Y. Okay, so work at the distance OH, so that's Y is what we're calling it. Vertical height at the top of the hill relative to points O and P. Give your answers to the nearest meter. Okay, same kind of story. How are we going to work backwards? Okay, we're trying to find Y. What do we know about the triangle Y is in? We know that it's a right angle triangle and we have an angle of 17 degrees. Okay, we know right angle triangles if we have an angle. If we have, well, because we're in right angle, we can straight away figure out this angle. that might help us later, but we don't know that yet. So we know right angle triangles, if we have an angle and another side, we can use SOHCAHTOA to get y. Okay, so that means we can either find this side or this side. And I would say find this side because this side is actually the side that sits in another triangle. And we can use stuff about the other triangle to find it. Okay, so we're trying to find this. Let's label that x. And how are we going to find that? Well, this here is a non-right angle triangle, and we know two angles and a side. Okay, well, we know two angles, so we can find out the third angle pretty easily using 180. And if we see that these are opposite to each other, and we know the angle opposite x, we can use the sine rule. Okay, so now we have a way to find x, and that will give us a way to find y. Okay, so now we need to go about finding this angle to find x to find y. Okay, so let's find this angle first. Well, this angle is in a triangle, and all angles in a triangle add up to 180 degrees. So if we do 188 or 180 minus 88 plus 87, that will give us 180 minus 88 plus 87. That will give us 5 degrees. So we know this angle in here is 5 degrees, and now we can use the sine rule with 20 and with 87 to find x. Okay, so we're going to try to find x. We know that the rate of change of x in relation to, 87 degrees. So as 87 degrees changes, so does x, is the exact same as the ratio that 20 meters changes as 5 degrees changes. So 20 meters sine 5 degrees. Now we're just trying to find x, so all we have to do is multiply across by sine 87. So x equals 20 sine 87 all over sine 5. Put that in our calculator. 20 sine 87 over sine 5. It's going to give us 229.16. Okay, so we know this x is 229.16, and now we're going to try to find y. So we said if we figure out what we know about the triangle y is in is that we had one angle and no other sides. We said if we found another side, we could use SOHCAHTOA. Another way we can think about it is, let's use SOHCAHTOA first. So SOHCAHTOA. Well, straight away we know nothing about the hypotenuse, so we can kind of get rid of sine and cos because they both contain the hypotenuse. So that leaves us with TOA, which is perfect because if this is opposite, this is going to be obviously adjacent. Think of opposite the angle, and just adjacent means beside the angle. Okay, so that means tan of our angle, 17 degrees, is going to give us opposite, so y over 229.16. Okay, and if we multiply across by 229.16, that means 229.16 tan 17 degrees is going to give us y, and that's going to be equal to 229.16 tan 17, going to give us 70.061. And they wanted to give your answer correct to the nearest meter. So that would be 70 meters. Perfect, and that is the whole question done. So again, same kind of thing. If we're dealing in real life, recognize what we're trying to find and work backwards. So now we knew this is in a right angle triangle with 1 degree, so we need to find another side, either this one or this one. We said we'd find this one because it sits in another triangle. And then in this triangle, we know it's a non-right angle one, so it's cosine or sine rule. And which one are we going to use? Well, straight away another way we could have figured it out was, for cosine rule, you need two sides running into an angle. You need two sides minimum. And we don't have that. We have 20 and this one running into 87, and we're trying to find that one running into 88. So it doesn't really work. So we can rule that off and just use the sine one. And if once we know we need the sine one, that means the only side we have, the opposite angle, we don't know, so we need to find that. So we need to find the angle, use the sine rule, find this side, then use SOHCAHTOA to find y. And our answer is going to be 70 meters. Perfect. So on to the next question. Okay, so next question was very similar to the last questions again. It's a kind of real world based kind of one. But this time the reason I chose it is because our answers are actually going to be in terms of letters and stuff. We're not going to get an actual numerical answer. And the reason I chose this is because just to kind of show you that a lot of people see these and they get freaked out when we're not getting a number at the end, but that's okay. This is exactly what they want, and we shouldn't be afraid of things like that. The same rules of algebra apply, and because the same rules of algebra apply, that means all the same rules of trigonometry apply, and because everything builds off of algebra. Okay, but let's jump straight into it. So it says P, Q, and O are 3 points on the horizontal ground, and SR is a vertical pole of height h. So this is SR of height h. The angle of elevation from S is 30 degrees, from P is 60 degrees, and the angle of elevation from S from Q. Oh, whoops, sorry, I already said that. So 30 degrees, 60 degrees. And we know P to Q is A meters. So express P or and or Q in terms of h. So if we think back to another question we had before where it was like J minus K, H over J minus K is equal to K. And it said express H in terms of J and K. So if we want to express something in terms of something else, all that means is getting the something on one side alone, just one of them, and anything, the things we want to express it in terms of. So in terms of means all on the right hand side. So in this case, in our last question, when we wanted to express H in terms of J and K, we just need to get H on its own this side, and everything with J's and K's on this side. And how we did that was we just multiplied across by J minus K, so it'd be K times J minus K, and now H is in terms of J's and K's. So H is alone on the left-hand side with an equal sign, and it's in terms of everything else. So now if we think about what that means for our question, we're trying to express P or, so this one here, in terms of H, and H is this. Okay, so how are we going to do that? Well, H sits in this right angle triangle here with 60 degrees, 90 degrees, and H. And if we draw this out, 60 degrees, and let's label this X. Okay, so what do we know about this right angle triangle? Well, because we're expressing it in terms of H, that means we can count this H as something we know, because we don't need to sub in a number for it. If we have X is equal to some kind of something to do with 60 and then multiplied by H at the end, this is okay. It's in terms of H. We don't need to sub anything else in for it. So this counts as something we know. So we know one side of the triangle, and we know an angle for the triangle, and we're trying to find another side. Perfect. That's our sine, cos, and tan. And which one are we going to use? Well, we don't know anything about the hypotenuse, so if we're thinking SOHCAHTOA, sine and cos are immediately gone because of this h here. So these are gone, so that leaves us with tan. Okay, great. And what that tells us is tan of 60 degrees, so the angle we know, is going to be equal to the opposite side, so h, over the adjacent side, so x. So opposite over adjacent, OH, or OA. Okay, and now we want to express P or, so the thing we called X, in terms of H. So we need to get P or, let's even call this P or. We need to get P or alone over this side, and then H's and stuff over this side. And how are we going to do that? Well, one thing we can do is, problem is P or is below the line, so let's get rid of that. So let's multiply up by P or equals H, and then divide by tan 60. So P or is equal to H over tan 60. And now we have P or alone on the left hand side in terms of numbers and H's. And so that means P or is expressed in terms of H. And we can even put tan 60 in our calculator, I think, if you really wanted to. So tan 60 is root 3. So you can say H over root 3. And now P is even more in terms of H and numbers. So p is alone on the left-hand side, and the in terms of is on the right-hand side. So that's the question done. So now p or is equal to h over root 3. Okay, and that's the question done. So next question, hence find the angle p or q. So this angle in here, p or q, given that 3a squared is equal to 13h squared. Okay, well, what do we know about this triangle that this angle is in? We know it's non-right angled, okay, and we know one side is equal to a. And we're trying to find this angle. And another thing we know about this triangle, let's even draw it out so it's not a weird shape. This is, would it be like if we're looking straight down on it from above, or from above this way. So we know this side is h, p, q. We're trying to find this angle, let's call it theta, and we know we already found out that p or is equal to h over root 3. Because remember, in terms of h, we're counting h as something we know. Okay, so again, we're counting a as something we know. We're given that 3a squared is equal to 3h squared, so a is something we know about the triangle. We know one side, we know another side, and we're trying to find an angle. Well, if we think about it, if we find this side, we have two sides running into the angle, and we know the side opposite it, and that's a dead giveaway for the cost rule. Perfect. So if we can find or q in terms of h, because this is in terms of h as well, then we can use that to use in the cost rule to find theta. Okay, so let's focus on finding or q. And let's draw another, I'll get this out of the way for a second. Yep, perfect. Let's draw another triangle like this, Q, S, or 30 degrees, H. And we're trying to find, let's call this one, let's just leave it or Q. Okay, let's find or Q. Same deal. We know an angle, side opposite, and side adjacent. So tan 30 degrees is equal to H over or Q. Multiply cross by or Q. Tan 30 is equal to H, or Q is equal to H over tan 30, which is 1 over tan 30 on our calculator is root 3, and so this is H times root 3 now instead of over root 3. Okay, so this is H root 3. Okay, and now we have two sides running into the angle and the side opposite it. So perfect, let's use that. A squared is equal to H over root 3 squared plus H root 3 squared minus 2 times H root 3 times H root 3 and cos of our angle that we're trying to find, theta. Okay, so we're trying to find theta, and we're trying to get that on its own. Straight away we know that we have two things we don't know. We don't know A and we don't know H, and that's one too many things, because we don't know A, we don't know H, and we don't know theta. And we only have one equation, so we're over defined. And so we're going to go back to the question and see what they told us. Well, they told us 3a squared is equal to 13h squared. If we divide across by 3, now we know what a squared is, and we can sub it straight in here. So that means 13h squared over 3 is equal to all this. Okay? When we're multiplying out, when we're squaring out fractions, what we do is we square the top, so h squared, and we square the bottom. When we square a square root, they cancel, so we're left with 3. Okay, same thing over here. If we're squaring something multiplied, we square the first one, h squared, and we square the second one, but the square root will cancel with the square, so that leaves us with 3. Over here, this is a h over root 3 multiplied by h times root 3. So if we think about one line kind of multiplying, top by top, bottom by bottom, let's call that 1. We know we can cancel above and below by root 3, so they disappear. And h times h is just h squared. Okay, we're getting somewhere. So now everything's in terms of h squareds. So why don't we bring everything with h squareds over here and then leave everything with thetas over there. So 13h squared minus h squared over 3 minus 3h squared plus 2, oh no, sorry, I can't do that yet, because this is tacked on to the cos, it's multiplied, is equal to minus 2 h squared cos theta. Okay, and so what is this equal to, this algebraic sum? Well, if we think about it, these are just like apples and oranges, and they're all apples in this case, they're all h squareds. If this was like 13 over 3 x squared minus x squared over 3, we'd be able to add these because they're both x squared, so it's the exact same thing as h. And this is why I threw it in. The rules of algebra still apply, it doesn't matter what letter it is. So 13h squared minus h squared over 3 is going to be 12h squared over 3, because think of like a 1 there. So 13 minus 1 is 12. Minus 3h squared is equal to minus 2h squared cos theta. How are we going to add these? Well, one thing we could do is multiply everything by 3. Actually, the 12 will divide by 3 anyway. So 12 divided by 3 is going to be 4. 4 minus 3h squared is just 1h squared. Is equal to minus 2h squared cos theta. Now, h squared is equal to minus 2h squared cos theta. We're trying to get to the cos theta. What's stopping us? The minus 2h squared. So let's divide across by the minus 2h squared. So h squared over minus 2h squared is equal to cos theta. H squared above the line, h squared below the line, they'll cancel. And we're left with minus 1 over 2 is equal to cos theta. And we know, okay, let's think about it for a second. Actually, no, we don't need to, well, okay, I'll talk about it. So if we think about our unit circle, we're thinking about cos, so we're thinking about our x coordinate. In this case, this would be like 1/2, but we want minus 1/2. So think of it, this is 0, so minus would be this way. So this would be minus 1/2. And so our point would be somewhere here. This is our x coordinate of our point, minus 1/2. So our point's here, we're trying to find this angle here. How are we going to find that? Well, think about the 2 points that are shared. So they both have a half and a minus 1/2. If we can find this angle here, then we can do 180 minus that angle. Okay. So, so let's find this angle here. How are we going to find that angle? Well, if we know cos theta is equal to 1/2, we can do cos inverse 1/2 is equal to theta. If I put that in my calculator, cos inverse 1 over 2 is equal to 60 degrees. So we know this angle in here is 60. How do we get this big angle there? That's 180 minus 60 is equal to 120. So now we know cos inverse 1/2 minus 1/2 is equal to 120 degrees. The problem with this is we know that this point down here also shares the minus 1/2 coordinate. And so, okay, let's find that. So if we know this is 60, all we need to do is add 180 degrees onto it. So 180 plus 60 is going to be 240. But if we think about an answer of 240 degrees for our question up here, that doesn't make sense because our angle obviously isn't beyond the 180 degree line, because then it wouldn't be a triangle. So we're restricting ourselves to things between 0 and 180 degrees, and obviously 120 degrees fits that, but 240 doesn't, so we're going to ignore that. So there are two possible angles, this one and this one, but we're going to ignore this bottom one because it doesn't make sense for a triangle. Okay, so this is our final answer. This is the angle of PQR. So angle PQR is equal to 120 degrees. Perfect. And that is the whole question done. So yeah, takeaways from this question is mainly that the same rules of algebra apply. It doesn't matter what letter we're using. If we're doing H's, X's, A's, that kind of thing, everything still works. Another point that cropped up at the end that I've forgotten about was that because we're talking about the unit circle, there are two values for theta. This one works for -1/2 as well, but we're going to ignore it because it doesn't make sense for a triangle. And I think even if you put cos inverse -1/2 into your calculator, it'll give you 120 degrees anyway, because calculators are pretty smart. But don't always rely on doing cos inverse, because calculators are also kind of dumb. And like I was saying before, usually they only give you this angle here, and they forget about this angle. But yeah, so that's the whole question done, and this is our final answer. So moving on to the final question. So final question says, a flagpole is attached to a vertical wall at point S. The pole is then suspended by two wires, PR and PQ, or PT and RT, and we know ST is 120 and QS is also 120. Okay, so, and PQ is equal to PQR is equal to 90, but everything's in the diagram anyway. Okay, so they want us to calculate PS. Okay, so PS is here, and if we think about it, this is flat against the wall. So sometimes these diagrams are tricky because it's 3D on 2D, but if we think about it, Q is directly under S because it's on the wall. So this whole triangle here, PQR, is flat against the wall. And so if we draw it here, PQRS, that means that this here is 90 degrees, this here is 90 centimeters, and we need to find this. Oh, and this is 120. So, well, obviously we can delete 1/2 because we're just focused on this. And this is a right angle triangle with two sides, and we're trying to find the hypotenuse. So that is just Pythagoras' theorem. If we call this this side A, this side B, and this side C, we know A squared plus B squared is equal to C squared. So A squared is 90 squared plus 120 squared is equal to C squared. So C squared is equal to 90 squared plus 120 squared. It's going to be 22500, and then if we square root it, that's going to be C equals 150. And so C here was also known as PS in our diagram above, so that means PS is 150 centimeters. Don't forget to put in centimeters. So this here is 150 centimeters. Now we need to calculate the length of wires used to attach the flagpole to each wall. So that's PT. Okay, again, if we think about it, this here is a triangle, PST, and instead of kind of looking at it in the diagram, let's just draw it like this. Actually, this is the problem. See, here it looks like a non-right angle triangle, but because S and P are on the same, they're flat against this kind of wall, they're directly below each other, looking at from the side. So that means it's a right angle triangle. It may not look it up here, but that's the reason. They're kind of trying to trick you out. And we just figured out that PS was 150. We know this is 120, and we're trying to find this, C, let's call it again, and we'll call this AB, and same thing, A squared plus B squared is equal to C squared. So 150 squared plus 120 squared is equal to C squared. C squared is equal to 150 squared plus 120 squared, 36900. Square root that. C is equal to 30 root 41. Okay, great. And so now we need to calculate the angle that each wire makes with the wall, TPR. So TPR is TPR And we just calculated this, and we know this. So if we this is our triangle we're thinking about, P, T, Q. That's our thing. We're trying to measure this angle. We just figured out that that was 30 root 41. And we know this is 90. And we know, because we're looking straight down, that this is 120. So let's measure this angle. Sorry, it's not going to be 120. If we think about, almost made a mistake. So this triangle here, this is 120, this is 120. So let's calculate this. So think about this side triangle that we just did. So SQT, that's 120, 20, right angle triangle. So 120 squared plus 120 squared is going to be 28800. Square root that. It's going to be 169.71. So 169.71, and that's 169.71. But we probably didn't even need it. Yeah, we didn't even need it because we're trying to find this angle, call it theta. It's a right angle triangle, and we can use sine, cos, and tan. So if this is our angle, this is our hypotenuse, this side here would be our adjacent. So K would give us A and H. So let's use cos. So cos theta is equal to 90 over 30 root 41. And so we can do cos inverse 90 over 30 root 41 is equal to 90 over 30 root 41, 62.061 degrees. So theta is 62, let's round it down, 62 degrees. Okay. So yeah, takeaways from this question is, don't trust their diagram, draw your own. Think about which triangle you're thinking about and draw your own one. But yeah, so that's the whole question. I'll leave you there, and I'll see you guys next week. Yeah, same thing, any questions you have about any of the questions we did, let me know and I'll run through them. If you have any other questions that you want me to do, let me know, no problem. But yeah, I'll see you guys next week.